Hello, and welcome back to another Rocket Academy video. In this video, we will continue to explore React, namely the useEffect hook, its use case, and how to implement it. If you recall from previous sessions, we discussed React lifecycles. These methods acted as triggers for our components, running functions and commands on load, or if a condition was met. useEffect is a single method that can be used to emulate these lifecycle methods: component did mount, component did update, and component will unmount. By developing code with useEffect, you can control how a component acts upon load, how it acts when it updates, and what code to run when it's unmounted. Let's explore the useEffect hook, which can be used as an all-in-one lifecycle handler. It should be noted that you can develop as many useEffects as needed, though they may affect one another. When using useEffect, you may want to make the code run only in particular instances, like if a condition is met. When declaring useEffect, the first argument is a self-invoking function. This is where we can write our logic. At this stage, we can discuss useEffect and how to use it in three ways. If we are emulating component did mount, then we need to fire off a function within our useEffect declaration. In the first example, useEffect is taking two arguments, the code to be executed and an empty array. It will run the console log once and only once. This is due to the empty array that is being passed as the second argument to this useEffect, similar to component did mount. If we want to execute this code every time there is an update, then we can invoke the useEffect method without any array. The second example is one of the most simple use cases of useEffect. It will run the console log every time the component is re-rendered or updated, similar to component did update. If you only want to run useEffect on a condition, like if the count has reached a certain number, we will then need to pass in a second argument to useEffect. If you populate the second argument, that array, with a state, the function will be able to run every time that state is updated. You are then able to add in any conditional statements to run functions or alter state. In the third example, the console log will occur only if the state that is stored within the array is altered or updated. It will run every time it is changed, similar to component did update, but in this case looking at a specific value. This is how you can make useEffect emulate component did update. You will need to track the data that is being updated for the component to call the useEffect method. The last lifecycle method that we can showcase within useEffect is component will unmount. This is where we'll run any teardown code for our component. For example, if our component was using setInterval in any location, we would need to implement a useEffect code to clear the interval within its return statement. This prevents memory leaks. As you can see, we can just put logic within the return statement that returns a function. And within this final example, we can run the console log when the component will be removed from the browser. This is when we unmount our component. This is very similar to component will unmount. To showcase the implementation of useEffect, I will create a clock component that updates on load. We will also create a toggle button that allows us to show and hide this clock component. We will do this within our previous React application where we were developing React hooks. Let's navigate to the terminal and open our directory. Within the components folder, let's create a new file. Let's call it hookclock.js. At the very top of our component, we're going to have to import both useState and useEffect from React. Following this import statement, we will create our functional component that is going to be named hookClock. We will use export default to export this component. Within the hookClock, we will create a state. We will do this using useState. Within an array, we define time and set time. We assign the value as useState with the initial state being a new date. Next up, we will create our tick function that will be used to update our time state within our useEffect implementation. So we can write const tick. We're going to make it an arrow function, and inside we will write the command set time with the value being a new date. At this point, we can create our useEffect statement. So we write useEffect and pass in an empty function. Within, we can define and develop our set interval. We are going to assign it to a variable that we're going to name timer ID. Our set interval function will run our tick function every second. We will also console log tick. This can be done inside the useEffect function, so we can see when our function is actually run. Now we can develop our return statement. Any component using set interval will need to be cleaned up. We must clear the interval before we can unmount the component. We write return and define a function, where we will call the logic needed to clear our interval. So we write clear interval passing in our timer ID. We will also console log unmounted. When the clock is removed, we want to stop the interval and then unmount the component. This is how we can implement the useEffect method within the hook clock component. useEffect will allow us to emulate component did mount with this code here, component did update with this code here, and component will unmount with the code at the bottom. We will create our JSX and write return, where we create a div. We will have our component state time and then use the toLocalTimeString method. At this stage, we can render our hook clock within our React application. Let's do this within the app.js. At the top of the page, we will write import hook clock, and we will also need to import useState from React. Then we define our state within an array, showClock and setShowClock, assigning the value of useState with the initial state being the boolean true. We will add this code right above our React link. Here we are going to define a conditional statement to show our clock if the showClock state is true. On the other hand, if it's false, it will display no clock at all. We will then also create a button. This button will be used to show or hide our clock. The value we'll give to the button is toggleClock. The button will need an onClick method where we can call the setShowClock functions. This is where we can pass the opposite of our current state. Now we can run our application and see our clock component in action. Look at the clock slowly count the seconds onwards. If we open our console, we can see that our hook clock is ticking, which is a result of our re-render. We can press toggle and that will just unmount our clock, therefore removing it. As you can see, there are no ticks, and therefore there is no function call and no memory leak. This is how we can use useEffect to implement a clock within our React components. You could use useEffect to call APIs utilizing Axios, run functions, or anything you need to execute when your component mounts. By implementing useEffect and useState within your React components, you are able to bring the complexity of class-based components into functional components. See you in the next video.